Hello students, now today we are going to discuss optical isomerism dear friend. Okay, because so many students are facing problem 11th standard, that is what we are going to understand, that is optical isomerism. Okay, this is also part of stereo isomerism students, where what is happening, that is few things are common student. Okay, what are the common dear friend, if you talk about what are the common? Okay, oh, something is problem. What is the common thing, student? Let us try to write that. So if you talk about common, so that is first one is molecular formula. This is the common for two compound or more than two compound. So molecular formula will be same. Okay. Now the second point, if you talk about, that is structure also same. This is also going to be same. So is structure same. So two things are same. So dear friend, what is the different? If you talk about what is different, friend, okay. So if you talk about different, student, in the position of, what? In the position of atoms, okay, atoms, or what, groups of atom, that is group of atoms differ in space. That is what the point, differ in space. So that is what the point, student, that is the relative position of atom will be differ in the space, but that is molecular formula, structural formula, all same. Okay, suppose student you see let us try to have the look over it. Here I am going the diagram here. One compound is there here, C, and that is hydrogen is there. This side, this is OH. Here is, that is, if you can write, that is CH3, and this side C double OH. Same you will find, student, here, that is similar compound we will find, that is here hydrogen is there. Here C double OH is there, right? Here is CH3 is there, and this is hydrogen. Now you try to understand, student, that is the formula is same, okay, and shape is same. There is no difference in formula and shape. You can find here there is no different in formula and shape, friend. That is what tetrahedral shape are there. This you can see, this is the tetrahedral shape. That is exactly. What about this one? This is also tetrahedral shape. So structure is also same. Four bonds are same. But what are there, student? Here OH group is, you see, left side, and here is OH group is how much? Right side. Acetic acid is left side, right side. Here left side. Okay. So these are the atoms or groups of atoms are differ in the space. Here left side, right side, left side. These are there. Now so when you talk about the structure, no, optical isomerism. So what is the, what is exact meaning of the things, student? Okay. Firstly, you try to understand optical activity. Okay, optical activity. So the rotation of PPL light. Okay, the rotation. Okay, what is, student, the rotation of PPL light? What is, student, PPL light? PPL light means what, student? Plane polarized light. Plane polarized light. This is what is meaning of the PPL light. Plane polarized light. The rotation of PPL light by the compound, by the compound, by the compound is known as optical activity. Is known as what, student? Optical activity. So that is what the point, student, optical activity. Okay, so that is, if the any compound is capable to rotate, if any compound is capable to rotate plane polarized light, okay, that is what, that will be the compound is optically active. A plane polarized light means what, student? If the light having the vibration only, what, that is up and down, okay, that is the, this way, if the light is coming, it is not like that the light should not come from all the direction. Okay, its vibration should not be from the light sunlight ordinarily. It is not like that. It's the common. It is the uncommon light. That is this type of light. If their rotation, simply you can see the light is traveling in this way, and this is what is happening. Here you will find, that is frequency is something you will find like that, student. Okay, this is a straight line. Here is the frequency, so sometimes it is up and down, up and down. That is the, here this is the, now that what is happening, dear friends, that is the optically active. Firstly, the how what they are saying, that is same structural, same molecular formula, structural formula, but differ in the position, relative position of groups of atom or atom in space. Okay. To be optical isomers, they should rotate the PPL light friend. Now, that is next point we are going to understand condition to be optically active. Okay. Condition to be optically active, okay. So that is what optically active. So first condition is what friend, first condition when you are talking about first condition, that is what carbon, okay, carbon should, or you can say must, okay, attached with what student, carbon must attach with four other group, four different group, four different, not the same, four different group. Okay, this is what, okay, known as what student, chiral carbon. This is also chiral carbon. This is what is known as chiral carbon. One more name is what is known as student asymmetric carbon. This is also known as asymmetric carbon. This is what the point is student. Means if I am having the compound student, what is meaning of this? This is the carbon. So here is A should be different, B should be different, C should be different, and D should be different. And this carbon is known as what student? Chiral carbon. This is what is chiral carbon. Okay, chiral carbon, and that is hybridization is always sp3. That is the first condition. Okay. Now, second condition is also they should not be what student? They should not be superimposable. That is what meaning of superimposable, superimposable on their image, on their mirror image. That is what the point is student, on their mirror image, right? They should not be superimposable on their mirror image. That is what the second point, dear friend. Now these 2 points are, that is what somewhat making us clear that the, these two, okay, points are making the compound to be optically active. And if they are not superimposable on their mirror image student, so that is what his name is what, enantiomer, enantiomers, right? So let us try to have the look over the compound student. Suppose I am having the lactic acid friend, lactic acid, okay, lactic acid. See, if you talk about the lactic acid friend, this is the structure of the lactic acid. Here is the hydrogen. This side you will find that is OH group. Here is that is methyl group CH3, and here is C double OH. Right. This is what. One more structure is possible, student. What this structure is possible? Here C double OH group is there. CH3 is as it is, and here is what is there, friend? OH group. Now this is the mirror image, student. Mirror. Okay, imaginary mirror. If you put this compound A on B, if you are putting this compound A on B on each other, so what you find, they are not going to completely cover it. It's not possible to cover, because here OH group is here and here is C double OH group. Not possible. So both are enantiomer. Now see this compound. The first point you see the central carbon. You see, student. What is this central carbon? This star. What is? Chiral carbon. Why this is chiral carbon, student? Why this is chiral carbon? Because it is having four different group, hydrogen, OH, CH3. This is also going to be what, student? This is also going to be chiral carbon. That is what the first condition is fulfilled. Are they superimposable, student? They are not superimposable. We cannot impose on each other. They can't cover each other. So that is both are what? Both are what? Enantiomer. Enantio. Enantiomers. Now, enantiomer is not superimposable. This is rotating the PPL light into clockwise, student. This is going to be clockwise rotation. PPL light is clockwise rotation. A clockwise rotation, student. If it is clockwise rotation, it means what? If it is clockwise rotation, it means what, friend? That is what is known as D-lactic acid. That is what is point is D-lactic acid. D-lactic acid means dextrorotatory. Also, you can say, student, dextrorotatory. I know dextrorotatory. Okay, rotatory. That is, this is going to rotate. What direction it is going to rotate, friend? It is going to rotate, that is left side. Okay, that is left direction. It means left direction means what, student? That is going to be anti-clockwise. Okay, anti-clockwise. It is rotating, the PPL light is anti-clockwise. That is what is known as L-lactic acid. This is what the point, student. L-lactic acid, right? L part, that is levorotatory, student. Levorotatory. Okay, this is what the point is, student. So what I means to say, student, that is lactic acid is optically active because of two things. Firstly, it is having the chiral carbon. Chiral carbon means that is carbon attached with four different groups, and non-superimposable for mirror image means they are not able to impose. Okay, its mirror cannot be imposed on the other. So that is not. So two way, one is rotating, that is clockwise, that is dextrorotatory, lactic acid. Another is rotating anti-clockwise, that is levorotatory. One more compound is there, friend. That is one is that is alanine. That is what is alanine. Alanine. In alanine, student, that is the amino acid. This is what, student. This is alanine is amino acid. Right. This is amino acid. Now alanine, if you see, student, it is, this is optically active. This is optically active. Optically active means it is representing, that is optical isomerism. Now what is the formula of alanine, student? Here see, that is hydrogen is there. Here is NH2 group is there. Here is CH3 group is there. Here is C double OH. This is alanine, right? Now another is there. Here you see, this is the mirror, friend. These are going to be mirror. Okay, what is other is there? Here is hydrogen. NH2 is group is now this side. Here is what is CH3 is common. Here this becomes C double OH. So this compound, if you see, friend, so carbon is C. What is happening with the carbon? This carbon. So that is going to be chiral. Why? Because this is having the four different group. This is also going to be what, student? That is going to be chiral. They are not going. They can't cover each other. So that is what, both are what, friend? Both are, that is, you can say, non-superimposable. Non-superimposable. That is what, non-superimposable. Okay, non-superimposable of mirror image. That is what the point. Non-superimposable of mirror image, friend. Now, so if they are non-superimposable for mirror image, that is what is known as enantiomer. Enantio. MERS. They are enantiomer. These compound, what is going to do? They are what? They are capable to do, student. One, this is going to rotate the PPL light into the clockwise. This is going to be the clockwise. So if it is rotating clockwise, that is, it is called D-alanine. This is what is D-alanine. Okay. This is going to be D-alanine. And what is, this is going to rotate in anti-clockwise. That is what is known as what is, student? L-alanine, right? So this is, that is dextrorotatory, and one is levorotatory. So this is what the compound. Now one more compound is there, student. That is what is, that is butane 2 all. Okay, butane 2 all. It is also, that is optically active. This is the optically active. OA means optically active. Now, student, let us see that is why it is optically active, friend, that we have to find out. Okay, so butane 2 all means what? CH3, that is CH, here is OH, here is what it will come, student? CH2 and CH3. So that is 1, 2, 3 and 4. So butane 2 all, that is okay. Now let us try to draw the structure. Here is C is there. With this carbon, this is the asymmetric carbon. Why? Because if you see this carbon, student, if you see, so with this carbon, here is CS3 group different, OH group different, ethyl group different, and hydrogen is different. So here I am mentioning OH, the H, that is, here is OH, then we can have, that is CS3, and here is what is C2H5. Now let us have the mirror here. Okay, this is the mirror, imaginary mirror, and then you see here what is happening. This is hydrogen. Here is C2H5. This is going to be OH. Here is going to be CH. Now, dear friend, this OH group, if you see this compound, so what you are going to find? This OH group is this side, this is this side, okay? This is left and this is going to be right. Okay, C2H5 right, so it is left. Means that is, they are the, firstly, that is, you see, that is, this is a chiral carbon. Why chiral carbon, student? Because this carbon has four different group. This is also going to be what? Chiral carbon, friend. Why chiral carbon? Because this is having 4 different group. Now, see dear friend, what we can be able to draw from it. So this compound is going to rotate ppl light, it means clockwise direction. This is going to be clockwise. So clockwise means that is D, okay, butane 2 okay, this is D butane 2 and what about this? This is going to rotate anti-clockwise. This is what is student, anti-clockwise. This is what anti-clockwise. So that is what student L butane to all, L butane to all. So that is what all about the optical activity student. I hope that you will be little bit enjoying with this video. Thank you so much for watching. Okay, thank you friends.